Maybe we could open the floor just very briefly to any sort of comments or concerns. How did you like that? Our program is done. Now let's turn to the most important part of it, the audience. Meredith, perhaps you could join me here. Instead of leading a section, Meredith has been dutifully live tweeting so that the internets know what is going on. Maybe we will be streaming the next workshop.
Hopefully we could. I'd like
Hopefully we could. So, feedback. Yes?
I mentioned earlier, in listening to several of the talks, it occurred to me that a useful research project might be to develop a tool to reverse engineer the grammars from implemented parsers. So look at the binaries and use some combination of fuzzing by feeding input to a path analysis to see where the code is actually going. Reconstruct the grammar, which you could then pull out, re-implement, and replace legacy parsers with better engineered parsers. For some it would be easy, for some it would be impossible, but it seems like there might be an interesting research project there for some.
Yeah, well, I mean, we saw, you know, some work earlier today, like in extracting session languages from, you know, from binaries, and also in going forward from, you know, okay, if we have a state machine, we have the message formats, you know, Prashant's work, we can, you know, we generate the protocol from that. So, yeah.
I mean, in some cases, you might not even have the documentation anymore, or even know what, you just have some code, you don't even really, you know it's parsing, you have really no idea what the language is.
Right. Law?
You're absolutely right that varies very much. I've reverse engineered a few applications with parse inputs, and some of them you actually see the author coding a state machine and a table inside the binary. And all I do is take that out. And others, it's just a bunch of parsing routines. And I guess it's not even really even context free. It's probably context sensitive language.
Jacob?
So we've been focused on kind of the cutting edge research du jour. We step back, where do you see LangSec in 10 years, and what do you think needs to happen to get there?
I'm actually so focused right now on the what needs to happen to get there that where there is actually a little harder to describe. I mean, there was so much work this year on session languages, you know, on the state machines of protocols. You know, Perry and I were talking in whispers basically about, is it time to go to the IETF and basically require not only you know, an ABF grammar for message formats, but also a both human readable and machine readable state machine description for acceptance on an RFC.
Would not be without precedent. The IETF has already made that a formal recommendation. I don't know if you've ever seen it or on me, but
I mean, 5234 is the ABNF definition, and it's certainly like recommended. But I'm thinking like, you know, can we make a push for honest to God acceptance criteria?
Let me supply yet another item. Last year, out of this roundtable came the idea to formulate CWEs that would be useful to code auditors. Falcon, you can wave. We presented a paper on this at the first IEEE SecDev conference, and it received some interest. And of course, now we have to forge the language and persuade the CWE people to take it. But we have broken ground on that work. And we want LangSec to be a part of every code audit. So that's a pretty good goal for 10 years. And then, of course, looking more ambitiously, we want the parsers that are written in 10 years to be written in parser combinators.
And in memory-safe languages.
And in memory-safe languages.
And in type-checkable languages, and so on and so forth.
More,
All these ratchets that Perry's been talking about, I mean, you know, these need to become part of build systems. Tooling needs to exist to support these,
I
and
think a big aspect of it is ad hoc language. Right? I think that's a really dangerous area. It needs to be addressed.
do you want to elaborate on that some?
Well,
By, like, what do you mean by ad hoc languages
so
exactly
I
here?
mean, all of these JavaScript apps that people are writing, they have their own little JSON language to talk to the server. I mean, we were talking about that with
I mean, in a way here you're talking about DSLs, right? I mean, which
yeah, exactly. But
people are going to need to learn good DSL design patterns,
exactly.
yes.
And that's what I'm getting at, right? Is that there are so many languages out there that never touch on RFC. I mean, they never get close to being RFC status, and yet they are extraordinarily prevalent, and you know, we need to affect them too.
That's a good point.
Okay, personally, I would like to sort of us to get off the topic of parsing. Basically, parsing is parsing, but I mean, I remember in 1996 there were some nice papers on the spin operating system which used language features to implement extensibility in an operating system kernel, and a nice paper about what features you need in the language to do what it is doing, and that sort of thing is pretty nice, using language for much more interesting purposes. And I'm sorry that we seem to have given up on things like that.
I don't know, have we?
we haven't really, but of course, it's easier to concentrate on that very code that comes into contact with untrusted inputs and gets exploited. You know, this is where most of your weird machines are. But as you recall, our starting paper, the formal applications, the security applications of formal language theory, it also branched out in the languages of events passing through a reference monitor, and similar concerns of systems design.
I mean, we didn't have any ELFBAC related work this year, but I mean, a big part of the whole point of ELFBAC is that loaders have languages too.
Right. And of course, not everything that people think of as parsing is parsing, right? And not everything that people don't think of as parsing isn't actually parsing. So your loader is definitely a parser. Your driver is very often a parser. As we have just seen, there are. Well, okay. So let me give you a specific example. What about the Intel management engine, which turned out to contain a parser?
And which you can apparently like DOS by like pulling a particular audio input on the dot connector high, which I find hilarious. You can shut off the web server by DOSing the entire management engine.
Yeah, but even the deal with admitting an empty credential, because parsing in C, what could go wrong?
Partials are important. Okay, let's aim higher.
Indeed.
Yeah, I mean, I think aiming higher is what we're trying to do, but we have to have the shoulders of giants to stand on in order to do that.
Another 10-year goal is that every data protocol that is being proposed to some sort of a major application, such as vehicle-to-vehicle communications, vehicle-to-infrastructure communications, any other critical infrastructure, gets its data reviewed for complexity and for the gotchas that will make interacting with that protocol a very, very painful security experience for all. You lose the security game at the point when you've designed an overly complex data format. This is where your parser differentials nest. This is where they will come to roost.
Gee, which parts of these things can we automate? So, talking of those tricks you just said, so putting the human out of the way, right? So, automating all the things and throwing it at developers. So, which things come to your mind?
Where do I start? I mean, if we go, I mean, if we just go chronologically from yesterday, right? Like incorporating fuzz testing into, into build tooling, like Rust has done. Automate generation of both parsers and unparsers. Automate generation of state machine languages. I mean, if we have if we have a machine readable spec to do it from.
And not necessarily automate, but make it easy to express grammars in the language. If you think of it, it's a shame that your most typical element of your most typical network protocol, a sequence of variable length options or headers, has no standard way of being expressible in C and requires a stepping pointer to go through the goddamn thing and dereferencing that pointer and casting that pointer, where you can't be declarative about a structure, an input structure that's this simple.
Meanwhile, in Erlang, that kind of stuff is first-class language operations.
Right. So this is not strictly speaking automation, but if this is made a part of the language by way of the language design, by way of the library, we'll be much better off.
Yeah, I mean, automation you need when you can't express things cleanly in the language itself. I mean, this is why Java has a giant code smell all over it. Because it's not just like, parsers for, like look at JAX-B, right? Like look at pretty much anything that that deals with EJB, right? It's all like code gets generated from XML specification type crap, because the language doesn't provide good support for for ways to configure these things.
Can I add something on?
Absolutely.
I feel like what we really, if we have kind of a platform-independent way to specify protocols, which obviously we have some of in the verification, but if we could sort of build a standard and then build tool support it, where it sort of says, oh, you want to implement a protocol, well, what's your finite state machine? What are your, say, regular expressions for your messages? And of course, it wouldn't force anybody to use that, but if that,
That's what I'm aiming towards. Yeah, that's the kind of tooling I want to see. Yeah, I mean, ultimately, it would be really awesome to be able to just like rip 2 appendices out of your RFC and just feed them to a couple of code generators, and you're done.
Yeah, and if we could get that
Possibly
made,
removing, page numbers in Word or something, but nothing significant.
but if that can become sort of if you can get people to start thinking of that as the default way to build a protocol,
Right.
and you don't even have to say, go analyze your protocol and prove this is regular, because you just have this thing sitting there saying, give me your regular expressions, give me your
Right.
SSAs.
And that is the goal. That is definitely the goal.
As is my tradition, I'll be bold here again. I'm really encouraged by this system that we have, all of the talks that I've seen here and elsewhere, about writing the parser in a memory-safe language and then simply linking that into an existing application that makes a very ratchet function. But I wonder if we might be able to leverage the power that languages have in causing people to adopt the most Pythonic way, or the most rusty way, if you will, of doing a thing, and actually get some language developer to include this in the standard library in the next version of their language. I know that, for example, at SecDev, some people who were working currently on the specification of Java 8 at the time were very interested in the work that we were doing.
And Scala at least used to have parser combinators in the standard library. I mean, I don't know. What do you guys? What are you guys' feeling about the Rust standard library? Like, do you think NOM could be folded in?
Probably not, because it uses macros and it's a contentious subject.
I see.
Because people think they're ugly.
People think they're what?
Ugly.
Macros.
Yeah. Basically, there's a new feature in NOM that should appear this year that will make it easier to write parser combinators like NOM but without macros. And I'll probably switch to that at some point.
Okay, so like it's something that we could work towards. I mean, because I was standing here thinking, God, am I going to have to friggin' port Hammer to Rust and do all of the LLVM JIT crap like in Rust? I'm sure we could. I'm not sure I'd want to.
Explicitly getting NOM into the standard library is undesirable. Like the language team is going out of their way to try and get things out of it, because if it's in the standard library, you're tied to a 6-week release cycle, right? And if you bump into bugs, like there's very little you can do about it apart from point release.
which is one of the reasons that like the libc crate, for example, like lives in the compiler, and the compiler comes with one because kind of made libc compile programs. But if you want to consume libc, its compiler, if you try to use the compiler's one, you have to fetch it from Coder, right? Because then you can actually get an up-to-date crate, and you don't like attach the compiler's release cycle.
Okay.
So like, broadly speaking, when package management sucked, like getting things into the standard library was good because then you could use it. But at this point, like now that we have a coherent package management story, like I don't think it's intrinsically good to bundle it with the compiler.
So if that's the state of facts on the ground in the Rust world, how do we work with that?
I feel as though if it were formally verified, this wouldn't be quite as big of a deal, but that might be too ambitious.
If not more formally verified, you mean?
Or am I just tripping over myself? It isn't already.
Well, there isn't a formal semantics.
That could be working on. There's an intermediate representation of Rust that's a bit above the LDN1, and that's being worked to translate that to the lean theorem cover. So, and since most of them is just array access, there's definitely something that should be done.
Well, you really want to do the verification against the source language. Anyways,
It's not the source, it's just the last thing between send to LLVM. So it's already pretty low level, but it still has type information.
Rust really lacks formal verification tools.
Well, because there isn't a formal semantics for Rust.
Yes.
A formal semantics for Rust would be something for a heroic piece of work.
I should make a logistical announcement. If you have a car parked with a hotel, apparently at 6, some sort of a timer rolls over, and they might charge you a lot extra. So just
If you need to move your
if you
car,
need
now
to
is
move your
probably
car,
the time.
yes.
I have to do that, so I would make
Okay, do it, Pete.
I think that if integrating something like NOM with something like Rust, making part of the standard library, is going to upset people because they're going to say things like, we've already got read and write. And if I write programs that do I/O, I'm just going to use those, and you're not going to bother using them. I think the way we win here is replace read and write with NOM.
I don't know.
Because whenever a program does I/O, it's parsing, implicitly or explicitly. So the way we win is we make it so that whenever whenever input is consumed, it's parsed to the subject matter. I think that's the only way.
I would agree with that. Just looking at, even stuff in C with doing meta copy and or reading one buffer into another. There's the old way of doing that, which I can't remember the function name all of a sudden. Stir copy or stir copy. And when you give people the option to do both, some number of people are still going to use the old one because they say, this one's good enough for me, I've been using it, it works. I think the only way to win is to let everybody only use the functions that they know how to use, and on the back end replace it so it's always doing the same thing.
Yes.
Something we had talked about is, could you build Hammer in such a way that you could basically provide a grammar and then you could poison, for example, scanf? That you could only use scanf on providing the grammar, but then would automatically generate, kind of like what Mail does, going from a data specification. So the only way you can take input rather than say cin or scanf is to go through.
Well, you can do that. If you're running a project, you can simply, make a requirement that you not use particular calls. But it's difficult to impose this on the world of monarchy.
Well, there's always
It's
going
not
to be a
really-
human process,
But
right?
it's not part of an individual project to even use tools to prevent the use of particular calls. It's just the issues are probably elsewhere. If people don't want to, if people don't want to do the correct thing, don't know what the correct thing is, that's the
so heavy-handed with this. It is that if what we've seen with TLS implementations is any guide, we'll just see a litany of posts on Stack Overflow saying, why yes, just tell it that its grammar is .star and it will be regular and everything will be fine.
Yeah, that will be a fabulous Stack Overflow.
I think that it would be neat to make it very easy and integrate parser combinator with the language so that the syntax is familiar to developers, shove it in their face, and then tell them that they don't need to use walking pointers anymore and see if they adopt it.
I hate every single character of the code that has walking pointers. I had to write some recently, and I felt unclean through the whole process.
I kind of feel like a question that might help us like explore the issue you just raised a little more would be, why don't more people use Erlang?
Because its syntax is unfamiliar and its standard library is unknown to people and they weren't taught it.
But I mean, if you're talking about like essentially moving a new syntax for like CN or FRead into the standard library of a thing, like that's a bridge you have to cross somehow.
People learned how to use standard library containers and override objects in C++.
So I think Lee's talk had a very relevant piece on this, right? How do you throw essentially a functional language piece of control code over to the people who actually do write the control code?
Yeah, I did find it really fascinating that it was basically C-type signatures and Haskell bodies. That was rad.
Yeah, so this is what we have to do. I mean, the answer why people are not using a language that they don't know for a code base that they do know is kind of obvious. They don't know it, they know the code base, they're scared. Ezekiel, you had a...
Yeah, so this is maybe a bit of a tangent, but coming from the perspective of not being a security person, caring about this stuff, and having experience doing web applications, I wonder, since like I've got to do parsing in the browser, what would I do? Like, because if I want to do parsing on the back end, well, that's probably a different language. If I parse in the front end, that's JavaScript. And now I have to have two different parsers, so I have to have a parser differential.
I did get Hammer to compile under Emscripten. I just have no idea what to do with the results I got.
That's Emscripten gives you like a virtual C environment that doesn't really talk to the rest of JavaScript.
Okay, so basically, like, it's not useful to Emscript in a library?
Probably not. But on the other hand, building a parser combinator library for JavaScript shouldn't be too hard.
Oh, yeah, no, I mean, like, the syntax that we used for the combinators in Hammer was actually inspired by a JavaScript parser combinator library.
But then if you've got a parser combinator in JavaScript, and you've got a different parser combinator, say you're using Ruby on the back end, do you have the risk of a parser differential now?
This gets us back to the question of formal semantics, because the body, right, of each combinator, of course, would need to satisfy the same preconditions, invariants, and postconditions in order for the behavior to and also the same side effects in order for the behavior to be identical.
I'd say as a practical matter, if you're going to have to write this anyway, this is a better way than the alternative ways to write it. And yeah, not having the same code base on both sides is risky, but like using a shotgun parser on both sides is worse.
Well, there is also the aspect of if your language is too complex, then you're doomed to parser differentials.
But I mean, I have been talking with Prashant and Mike about getting some formal verification into Hammer, and we're like evaluating tools for that. And maybe we should talk with you about that some, Perry. I mean, just because to start with, there's some underlying data structures that that we can prove some invariance about.
It might be a substantial undertaking, but let possibility would be to have one canonical representation for the grammars, and then have bidirectional transformation. So you have one that goes into C, one that goes into Java, one that goes into JavaScript, one that goes into Erlang, one that goes into Haskell.
Isn't that
And
similar?
then, but the point is, by going in both directions, if somebody writes it in JavaScript, because that's what they're familiar with, they can automatically translate that JavaScript code into the standard one, and from there generate the Java on the back end or whatever, and have exactly the same grammar.
Is there a formal semantics of JavaScript?
No. I'm saying you have
If you answer this question.
you have a stylized script. So in other words, the user writing JavaScript in a very canonical way, it's going to be familiar to them because they know JavaScript, writes out this grammar. As long as they follow this template, essentially, then some mechanical tool could take that and lift it into the...
The tricky bit is that the tool needs to generate equivalent code
So
between...
here is the answer to your question, but you're not going, but although the answer is interesting, it's not what you want to hear.
Okay.
So there is, in fact, a formal semantics for JavaScript built as in like K, which is a really cool system. And it's an executable formal semantics, and it passes the entire ECMAScript 5.1 performance test suite. But here's the problem. No other JavaScript implementation even passes 90% of the suite. So JavaScript has this problem of many different of language version skew. So the formal semantics that someone has done for JavaScript apply to exactly none of the versions of JavaScript that actually exist in the field.
So every JavaScript implementation is terrible. Great.
What I'm suggesting is much simpler.
No, I understand.
You don't need a formal semantics for the entire language. You just need to be able to recognize this canonical script that defines the grammar.
Right. Yeah. No, I get where you're going on the front end. I'm just worried about equivalence on the back end.
Isn't that similar to just an extended protocol buffer, where you have some neutral language that describes the format of data, and then it will automatically generate parsers?
But then that's another language everybody has to. In other words,
Yeah.
the point is, what are the ingredients by letting people phrase it in the language they're familiar with?
Yeah.
If you're in C, you write it in C strings. If you're in Lisp, you use whatever. You know, every language would have its own way of expressing it. It would seem natural to that program.
Same, right?
Yeah, essentially
Yeah.
the same. It should be very trivial to
Uh,
map from one to the other.
Since you mentioned protocol buffers are actually exemplary in that what they actually implement is a very simple and minimal context-free grammar. If you're writing a protocol buffers implementation, then you are forced by this API to not create anything more complex than a context-free language. Of course, you can absolutely screw this up by creating or implying dependencies between the objects that you extract. And you can add all kinds of context sensitivity to your resulting language. But pure protocol buffers where you do not create any or imply any dependencies between what you unpack is in fact context-free. And it's that language of designing your data packaging that could be translated to other languages, because it's intuitive. I mean, essentially, it's simple productions, each production being regular.
So then should we stick with protobuf?
I asked this question. I asked these questions of Googlers, who of course see quite a large code base in protobufs, and people do create dependencies between objects, completely breaking the nice property of protobufs. And so yes, and this is of course where fuzzers have a field day.
Just for the syntax, so for the idea of having one description of the grammar. I mean, what you're describing, these interdependencies, one has to figure out in either way.
Protobufs are essentially, the protobuf API, you can look at it as essentially a way of descriptively writing down a grammar as code. This is important. I mean, if it looks like a grammar, well, it is a grammar in some sense. It is a grammar in the most important sense.
You need a front end for Hammer getting this in there and for Norm getting this in there?
Well, I mean, both Gnome and Hammer have their own ways of describing a grammar via parser combinators. But yes, this would be very simple parser combinators.
I mean, I think you could write a grammar in either Nom or Hammer for the protobuf wire format, for instance.
Yeah, you totally could.
What does that get you over using their?
I'm not sure.
So the question is where it's getting them, and it's apparently saving them quite a bit of development effort. Should this approach be applied elsewhere, it should save other people quite a number of development hours.
I mean, the problem I see though is like vendors and vendor consortia in particular tend to not want to write protocols that are simple enough to be described in the form of protobufs. And some of that is competition from each vendor trying to get their special feature into the into the control system spec or whatever. But it ends up just piling epicycles on top of epicycles, and so you end up with long distance data dependencies and stuff.
Oh yes, here is another 10-year goal. Try to instill in industries that handle critical infrastructure, such as energy, the idea that designing protocols by committee, and that the protocol is somehow a vessel for accommodating everyone's features. And this is the nice thing to do because you're creating a consensus. You're being nice to all of the members of the consortium. This is exactly not the nice thing to do.
And this is like an actually hard game theory problem, right? Because we're going to have to fight human nature here, and that's never a good idea. But I kind of don't see a way around it.
But this is the very opposite of nice, because you're dooming everyone to a hell of insecurity for, who knows, decades. Of course, your typical piece of infrastructure equipment is supposed to serve 20 years, at least.
But where's the liability, right? If toll fraud was a big deal to the analog cell phone operators because somebody had to pay for that.
Well, the losses are more evenly distributed. And
commoditization of loss.
I wonder if Cyber ITL might be some people that would be interested in some proofs of maybe the follow-on to the same type of work that needs to be done to push the CWE endgame here. If we can again find some concise list of this is the extent to which that pattern that Meredith is describing increases your risk, it might be a good lever to push on to ban it, or at least discourage it.
I'm not sure how linearizable that is, but it's worth exploring. Yes, absolutely. I mean, I suspect it will probably be more qualitative than quantitative, but
there has to come a year when protocols as just a repository of everyone's desirable features just stop being that, when this trend is reversed, when the fight is for getting the least amount of fields in the protocol. And this is seen as the nice thing to do. That, in fact, is my personal program for talking to power industry in a couple of weeks.
If you want an extra feature of the language, you cough up $100,000, and that goes to a security team that's dealing with all the issues that you created.
The cost of a length field traditionally has been quite high. The cost of a variable width structure is quite high. I mean, look at.
Well, I mean, hell, DNP3 literally had $1 billion mistake in the spec. There was that zero length string resolved to a null pointer.
I'll give you one more. IPv4 options, which now you would not really find in the wild because it turned out that they were just trouble. And then, of course, IPv6 extension headers with their chains are costing people a lot. I've heard from some operators that they're dropping 40% of all incoming packets of a certain kind in IPv6 on the floor.
Who was
So-
I having a conversation with about insurance earlier today? May have been you. I think it was actually somebody else, but maybe that person is still here.
I was having a conversation with someone about insurance. It actually was not.
It wasn't me, but I was thinking that this thing that you're addressing right now is something that I, in my penetration testing consulting work, have taken to calling the premature extensibility anti-pattern. It's going to be premature optimization anti-pattern. This is the same place from which we get ubiquitous reflection in Java, frankly. It's just this push that people have to ensure forwards compatibility and extensibility, even though they don't yet know what they think they're going to build. Almost none of these hooks ever get used, and if you look through old RFCs, you'll see a literal graveyard of extensibility features that were never used in reserved fields.
Some statistics on how close to none that is would be useful if you could start keeping track.
Yes, I am very busy, but if somebody wants it.
Well,
The IPv6 flow label is a fast studying this, but there are all sorts of things. I mean, the thing is, though, that most of them are benign because they're fixed length fields that no one uses, and so you can simply ignore them. The problem becomes when things become complexing like this. I'm actually reminded of something, which was that when the time came to decide whether IPv6 would get the same Ethernet packet type, because there is a field in the v4 format that has the IP version number in it. It was decided that no, you could not use the IP version number to distinguish different types of IP because all of the older versions of the thing probably didn't know how to parse it or deal with any other value in that field, and it was too dangerous. So most of the time when people actually do things like this and leave them fallow too long, they can't be used anyway, even if you do come up with a use, because there's too much fear that code in the field will explode when it is confronted with any different value in the field that it's seen traditionally.
No, that's right. And really, the flip side of that same anti-pattern is that it is an instant parser differential when the next version is released.
we did make an attempt to start speaking the language of patterns and anti-patterns. Our SegDev paper was about anti-patterns. Our login article in the past issue was about how we can represent recognizers and unparsers as design patterns familiar to people who actually do design patterns.
It is the interpreter pattern, literally. I mean, there's an entire chapter on this in Gang of Four.
We're coming up on the end of our time.
Oh, are we turning into a pumpkin? Okay.
We could go on, but it's been a long day.
We can also do the traditional. Everyone goes out drinking at what is that place called? Yes, St. Peter's Square Market.
Yeah. Could we have the last slide? I think I remember which button to press.
But nothing is projecting.
But nothing is projecting.
I could throw out one more quick idea while we're waiting for that. Seems like a really low hurdle that could be put into the specifications of the RFCs or IETF would be that anything that goes into the definition of a language should be formally and concisely specified, but for some definition of formal and concise. Because it drives me crazy when I'm looking at a specification and you have to read 4 paragraphs of English to understand the exception to or the linkage.
Right, because they could do it in just a couple of lines of ABNF, exactly.
Yeah.
And if you can't do it, then there's something wrong. If you need 4 paragraphs of English to explain what you're doing, you've made a mistake.
Yes.
That exactly.
This is something Sergey has pointed out to me in several RFCs, where you do have state diagrams in there that explain to you how the protocol works, but then when you actually reading the text, there are other features that are explained but not shown in the state diagram.
I remember going through XML, like it was driving me crazy, some of these weird rules. and then I went through the logs of error reports at the beginning, and somebody had said, when I do this and this and this, it doesn't behave the way I want. So they almost verbatim took his message and said, when this happens, this should happen. And that became part of the definition. It was just bizarre.
Regardless, and when it has machines, when it has, machine-readable definitions, or at least formal language definitions in a specification, and English, and there's a conflict, the machine-readable stuff should always be normative and not be English.
Agree.
The English is informally to explain things to human beings.
Yeah, like if you screwed up and you explained it correctly in the English but incorrectly in the formal notation, too bad, you get to revise it. That's why there's a comment period.
Well,
Do you think it's likely this will occur?
We just started talking about this today, so I don't know.
Well,
Wait.
no, it makes so much sense. I mean, if the spec is well defined, how you expect anything to come out of it.
But I mean, that's what happens in the wild.
I know, I agree.
Yeah.
So yeah, it seems like that's a great place to start. Keep the spec defined correctly.
And I think a lot of it comes down to the fact that these specs are designed by committee who wants to set as many features in there as possible, and nobody who's implementing these actually wants all those features. So, if for something like DMP3, everyone implements a subset.
Well, there's a lot of standards bodies out there too, right? I mean, like, we can go talk to the IETF, and I my feel for that is, like, I think they'll probably, like, be receptive.
They'll probably be receptive.
But,
Yeah.
like, IEEE, that's a standards body too. ITU, that's a standards body.
Actually, it means like some LangSec people in every committee, because going to the IETF and saying you should do that kind of thing and actually implementing that in process, it needs active participation, I guess.
Which means, like, going and packing committees, which always feels kind of like sketchy to me, but, like, I guess we gotta.
It also means actually, traveling to wherever IETF is 3 times. Because if you want to have influence there, you have to be, the face time is very important. You press the flesh in the bar, or people do not pay attention.
One of the things that might help us get momentum on this is that one of the CWEs that we're trying to propose in that prior work that was mentioned is incomplete or incorrect specification.
That's true.
So if we can
Get MITRE to pick that up.
in getting MITRE to take that up and find the appropriate examples and mappings and reasons why it is like literally nothing else and all the other things that they demand to be filled in, snippets of compliant versus non-compliant code, etc., that will take approximately a year to get together. It might be a very easy sell to the standards committee to say, please help people avoid the CWB.
Yeah, I mean, that applies to every standards body. All right, so I guess we're pretty much done for this year. Thank you all very much for coming. This has been a really fantastic workshop.
Yeah.
I mean, the papers were like a cut above this year. This was really, really great work.
A round of applause for the authors. And for the remaining audience. If it were
Yes.
not for you, we would have no workshop.
Thank you also to our sponsors, WideOps and ERNW GmbH.
And the previous sponsors who helped us get off the ground. And thank you for coming.